What's up everybody? Welcome to CPDict. In this video we are going to look at the problem C from today's Codeforces diff to round 675. Let's get started. The problem is called bargain. So we would be having some bargaining in this problem. Right now Sasha and Vova cannot come to an agreement. Sasha names a price as high as possible, which is n, and then Vova wants to remove as many digits from the price as possible. In more details, Sasha names some integer n, Vova removes a non-empty substring, which means consecutive digits, from the price. Remaining digits close the gap and the resulting integer is the price. Suppose from this number given by Sasha, Vova remove 1312 substring from it, then the resulting number would be 121. And yes, after removing some substring, it can have leading zeros. We'll be considering if all the digits are 0, its value would be 0. Then what we need to do, Sasha wants to compute the sum of all possible resulting prices after Vova's moves. So we would be considering all possible Vova's moves which he or she can perform, and we would be finding out the summation of that. So if you see the input, the range of input is from 1 to 10 raised to the power 10 to the again raised to the power 5. So we cannot have an integer which can store this much value, so we'll be taking this value as a string. Let's see what we can do. So at this point I'm a little skeptic whether I would be able to explain the solution efficiently or not, but we'll find soon enough. And before jumping on the solution, I just want to explain you few terms or values which I would be using in my solution. And yes, let's first pick an example. So I would be using this example. Suppose the Sasha has chosen this number 1, 2, 3, 4, 5. These are the indexes. Now I use few terms, which is prefi and prefsumi, suffi and suff of sumi. Again, there are more terms. Wait, hang on. There is the power of 10. Let's see what I've named it. Named it as tens I and some tens. Yeah, these are the 6 things. These 6 data structures or arrays which I would be using in my solution. Yep. So if we move in this string from left to right, I would be considering the prefix. Let's say we are talking about pref. Then the prefix at this index is 1. Here it is 1, 2, is 1, 2, 3, is 1, 2, 3, 4. At this last point it is 1, 2, 3, 4, 5. Now the second term which I used was prefsum. It is basically prefix sum of this pref. So it would be 1, 13 plus 123, which is 136. Now 136 plus 1, 2, 3, 4, but I can just write down 136 and plus this term. So I'll just add up. This is the pref sum, is the prefix sum of this prefix. Similarly, I found suffix. So in this I will move from right to left. At this index it would be 5. Here it is 4, 5. This 3, 4, 5. It is 2, 3, 4, 5, and at this place it is 1, 3, 4, 5. Similarly, the suffix sum is the suffix sum of this suffix we are having. So we move from right to left. Here it is 5. Now 5 plus 45, which is 50. Now 50 plus 345, it is 395. Again, now I'll add this. I'll add 3. So I'll keep on adding these values to my suppose. So this is a formula. Prefix sum of I is equal to prefix sum of I minus 1 plus pref of I. I don't know why I might have written it incorrectly. Let me check. 13 plus, yes, I guess this is right. Similarly, to find out the suffix sum of I is equal to suffix sum of I plus 1 plus suffix of I. So it is again, I guess it is right. So we'll keep on doing this. These are the 4 terms and the 2 terms are remaining. This tens I is basically 10 raised to the power I. So tens 5 would be 10 raised to the power 5. And yes, I am during the calculation of all these terms, I am also taking the modulus of it. So it will not go beyond the range of integer. Here as well, whenever I'm finding out these terms, and I'm continuously taking the mod of it, taking the modulus of the given value which I was taking. Now this was the 5th term, and the last term is sum tens I. It is basically, let me give you one example. Sum tens 2 would be tens 2 plus tens 1. So it is equal to 10 to the power 2 plus 10 to the power 1. So we can write it as tens I plus tens I minus 1 to tens 1. It is going till 1 only, and of course I am taking the modulus of it. So these were the 6 terms. I hope I have explained them correctly. Now I'll be going through my solution. Now let's again write down the example which I was talking about. 1, 2, 3, 4 and 5. So I would be going in this substring from left to right from one index at a time. Like I'd be considering one index, and at that index I would be considering all the substrings which starts at that index. For example, suppose I am talking about this index, the index 1. Now then I'll be talking about the substring which I am removing, again, which the VOVA guy is removing. So if I'm talking about this index 1, which is having the element 2, then I would be considering the substrings which is only 2. Second one would be 2 and 3. Third one would be 2, 3, 4. And the fourth one would be obviously be 2, 3, 4, 5. Yeah, actually I've covered 2 cases separately. So let me just explain them first. So the case when VOVA is deleting a substring which is containing the element 1. There can be 1, 2, 3 and 4 cases only, because VOVA cannot remove all the digits, and this was one constraint. So I've considered this case separately. Similarly, the case when VOVA is deleting a substring which is containing the last digit. So those substrings would be this 1, 2, 3 and 4. He cannot delete all the digits. So again, it is 4 substrings and 4. I'm considering these 2 cases separately. Then I was considering all the other cases, all the other indexes in a similar manner. Now, for this, for the first part, 1, 2, 3, I am writing this again and again. It might turn out to be a pretty long video. So I'm talking about the case when substring which is being deleted is containing the first digit, which is 1. So whenever it is deleting this one, the answer or the remaining digit is 2, 3, 4, 5. Whenever it is deleting the substring 1, 2, the remaining digit is 3, 4, 5, 3, 4, 5. And when it is 3, it is 4, 5, and when it is deleting till 4, it is 5. So, and we need to add up all this, as Sasha wants the sum of all the possible substring. So if you see, it is the sum of the suffix of this, and this. Like these all are the suffix. Suppose this is the index I, then the summation of these 4 values would be suffix sum of I. So we can simply find out the answer for this case from this value, and I'll explain how I'm calculating this suffix I value. Similarly, for the second case, when I was considering the substring which is containing the last digit, so there can be 4 such numbers. Suppose O was deleting only 5, then the remaining string is 1 2 3 4, and if it is deleting 4 5, then the remaining string is 1 2 3. It is deleting till 3, then it is 1 2, and the last case, if it is he is deleting 4 digits, then it is 1. If you see, this is the summation of first 4 prefix 1 1 2 1 2 3 1 4, and if it is the index I, then we can find out this value in our prefix sum of I. And again, I have explained how I am calculating this value. So yes, I have considered these 2 cases separately. Now I'd be talking about the all other cases. So let's say 1 2 3 4 5. So I've handled the substring which starts from 1 and which ends at 5. So now I'll starting from index 1, and I'll go till index n-2, as it is 0 based. So this would be index n-1. So I will be considering these indexes only from 1 to n-2. Suppose I am at this index, which is 1, is containing the digit 2. Now I will surely be deleting this digit. Now I want to find out how many substrings can VOVA delete in which 2 is there, and the substring starts from 2. Okay, so substring that starts from I and it ends before the last element, before the last digit. Yeah, because see, if we talk about this case, this is already been handled. This is already been handled in this case when I was considering a substring which is containing the last digit. So I will not be considering this case. Apart from this case, I'll be considering the 1, 2, and 3. These 3 substrings. The substring which starts from index I and ends at index lesser than n-1. So we cannot delete the last digit in these cases. So okay, so let's say I'm considering this first substring which is containing only 1. Now when I delete 2, the resulting string which I would be getting would be 1 3 4 5. So how can we, the way we can find out is 1 into 10 to the power 3 plus 3 4 5. And if you see, this one right here can be find out by pref of I minus 1, and this is 10 to the power 3, which is basically the number of elements which are after this particular index. Like these, there are 3 elements. This is 10 to the power 3, and 3 4 5 can be find out by suffix of I plus 1. Okay, now let's consider the substring 2 3. Now after deleting this substring, the resultant number would be 1 4 5, and this can be find out by 1 into 10 to the power 2 plus 4 5. Now again, 1 can be find out by prefix of I minus 1. This 45 can be found out by prefix of these indexes. Like suppose this is index y, then it would be suffix of y. And 2 is the number of elements which are remaining when we have deleted this substring. Like we have deleted this substring containing two elements, 2 and 3, and after that we are having two more digits to it. So that's why we are multiplying it by 1 into 10 to the power 2. So if you see, if we keep doing it, and we can find out a particular formula for that. So what would be that formula? Again, hopefully it would be last time I'm writing this example. So let's say I am again considering this string. So when I'm deleting only this substring, the resultant digit would be 1 into 10 to the power 3 plus 345, and when I'm deleting this substring, the answer would be 1 into 10 to the power 2 plus 45. When I'm deleting this substring, the remaining string would be 1 into 10 to the power 1 plus 5. Okay, so do you see some pattern here? And we need to add up all these values. So if we add up all these values, it will come out to be 10 to the power 3 plus 10 to the power 2 plus 10 to the power 1 plus 345 plus 45 plus 5. And now if you see, this one is nothing but prefix of I minus 1 into, and this term right here is sum 10 of 3. I explained what sum 10 is. You can go back to that part, and plus you see this 345 plus 45 plus 5, 345 plus 45 plus 5. If I go back to those examples, you see this is nothing but suffix sum, like summation of these three values. I'm storing it is in suffix sum array. This is nothing but suffix sum of I plus 1. So the formula turns out to be this. So I would be doing it for all the indexes. This 3 can be found out by the number of elements after this current index. Like this is the index I and this is the index n minus 1. So it can be found out by n. Suppose this is 1 and 2, 3, 4. So it can be found out by n minus 1 minus I, simply by these are the number of elements which are after this index. So this 3 was found out by that value. This is simply the prefix of I minus 1. This is the suffix sum of I minus 1. Please take mind that take a note of that this is suffix sum and this is prefix of I. So similarly I have done the same for all the indexes. Let me give you one just last example. Suppose I am considering this index. Then the answer would be prefix of I minus 1 into sum 10 of 2, as there are two more elements after this index, plus suffix sum of I plus 1. So for this, I'll keep on doing this for all the indexes, and I'll go till this 4. I will not be considering the last index because I have considered those cases separately. The substring which is containing the first digit and all the substring which is containing the last digit. I've considered all those cases separately. So yes, finally, let's see the code now. So these are the 6 data structures or arrays which I was talking about. First, I've taken the input for the values of n is equal to 1 and 2. I've handled it separately. If n is equal to 1, we cannot delete any digits to it because there is only one digit and VOA cannot delete all the digits. In that case, answer is 0. If the length of our string is 2, then there can be only 2 possible deletions. Either VOA can delete the first digit or he can only delete the last digit. So the answer is first digit if he is deleting the last digit, and it is the last digit which is the second one if it is deleting the first digit. Otherwise, yes, I moved on with my solution which I had explained. I've calculated the values of these tens and some tens, and during my calculation I have also taken the mode of it and taking the modulus value. These are the mul mode function which is basically multiplying these two terms and taking mode. Add mode is performing the operation. It is adding up these two values and taking the mode of it. And now I find out the prefix value and suffix. This is for the prefix one. For each index, I am calculating prefix by multiplying the previous prefix by 10 plus adding up the current digit. And that's for prefix sum, I am adding the previous prefix sum to the current prefix value. Similarly, for the suffix calculation, I am multiplying the current digit with the weightage of current digit. Weightage is P, it can be 10 to the power 2, 10 to the power 3, and adding the suffix which was after the current index, like to the right of it. And this is the suffix sum. I had explained the formula of it. And yes, this comes the main part. This is the case when I'm considering all the substrings which is containing the first digit. Yeah, and these are the cases when I'm considering all the digits which are being deleted by VOVA and it is containing the last digit. Like here, the substring which is deleting, here it ends at the last digit, and in this case the substring which is deleting, it starts at the first digit. And for all other cases, I'm handling it in this for loop. First of all, I'm finding out the multiplication of, let's go to the formula, prefix of I minus 1 into some tens of these values. Like, this is for this part. Now I just need to add up suffix sum of I plus 1. So to this value which is 10, I'm just adding up suffix sum of I plus 1. And I'm adding it to my current answer, taking a modulus whenever I'm adding something to it, and at the end I'm printing the answer. These are the addition and multiply functions. You can see it. Yes guys, I hope that's all for this video. I hope you liked it. It turned out to be a long video as I expected it to be. So if you understood something, please like, share it with your friends, and consider subscribing to our channel. Yes, take care, happy coding, sayonara.